As a computer company, Quanta is good at high-speed signal design. Therefore, ADAS and Level 4 autonomous driving has been our core. We invested more and stepped into traction inverter business. Traction inverter prioritize high power electronic and real-time control for motor efficiency. A single program can involve 30 more departments, hundreds of documents, thousands of components, multiple global production sites without a connected system, and that lead to late issues, especially in manufacturing. We realized we need two things. First, one single digital backbone connecting documents and the tools of design and manufacturing. Second, the ability to validate production line before we build it physically. That is the key to preventing us from making mistakes, and then we save time and cost.
Quanta is specializing on computing and automotive electronics. They actually master the complexity of these high-tech products together with the high volume production. Quanta uses a wide variety of solutions from Siemens. They have Teamcenter as the backbone for the data. They use Process Simulate to virtually validate all the processes on the shop floor. They have Workflow Canvas to program the automation side. Quanta needs one digital backbone that helps us really connect manufacturing with engineering. So Process Simulate was introduced next to simulate in the virtual environment what the robots at the shop floor actually are doing. Yeah, the main problem was never just how to design a product, but also how to make it manufacturable. So naturally was to create a virtual twin of the production itself. So Process Simulate is a virtual representation how the robot functions. So through the simulation, you can validate that once it goes on the shop floor, it's actually working as desired. Once it's validated, it goes into Workflow Canvas that programs the automation layer.
Techman brings flexible AI-enabled robotics together. We connect the digital validation to physical execution. Simulation allows us to validate everything before production starts. We can test the robot reachability, camera visibility, collision detection, cycle time performance, with simulation on production line, and ensure we start production with confidence.
The future of manufacturing is clearly digital. You need a backbone, you need a digital thread to connect to it, and you need the simulation tools to virtually validate everything before you go in real life on the shop floor.
We have seen measurable results, 15% higher efficiency from design to manufacturing, 30% faster commissioning time, 20% less documentation effort, 95% data consistency and traceability. But more importantly, the way we work has changed. By digital twins, scaling across factory become predictable. Looking ahead, this is how we industrialize innovation globally.